Right, we're starting the next chapter, chapter 6, hypothesis testing with discrete variables. We've already done it with continuous variables, so some of the concepts we've used then will just keep going with this. So I'm just going to go straight into an example and we'll discuss what you might want to do and we'll see whether or not you've got the right ideas. So I'm not going to write it out in full, but basically we have some medicine which historically cures 2/5 of people who use it. So we have some medicine, historically it cures 2/5 of the users. Now a new drug has come along and there's a claim that it's better. The claim is it's better. There's been a clinical trial, and in the trial it cured 11 out of 20 people. And what our job is to test at the 5% significance level whether or not the new drug is better than the old one. If you think about it, this is quite a common real-world example. There's millions of pounds in the drugs industry, and that's not the illegal sort, that's the medical sort. There is billions probably in both actually. So this sort of thing is very important. I mean, there are clinical trials, all sorts of things. When I was at university, one of the options I did in my degree was in medical statistics, and that's a huge area of sort of testing things. Is it worth it? The government want value for money. You see in the papers and on the news sometimes that NICE, which is the National Institute for Clinical Excellence, now decide that the NHS can use this drug, can't use that drug, and all sorts of things. And a lot of it is done on medical testing and things like this. So here we go. Let's just look at the scenario. We've got here 20 patients, 11 of them cured. Any distributions we have dealt with so far, would they fit this scenario? Because we need to think about our distribution first of all.
Would be binomial?
Binomial is correct. So can you tell me why you thought it was the binomial?
You had the number of successes in the number of trials.
Yeah, okay. First of all, here we had a fixed number of trials, which in the binomial we call n, and that was here 20. We tried it on 20 people. And then what we have done here is we have counted the number of successes, which we usually call R, and that was found to be 11. What other parameter did we use in the binomial distribution other than N and R? P. So P was the probability of success. Well, all we had to go on initially was it's supposed to be 2/5. So probability of success historically is equal to 2/5. So yeah, it is the binomial distribution, so well spotted, Lewis. Okay.
Why is the probability of success 2/5 when it's a different drug?
Well, historically it was. So what we've got to see is, has that changed or not?
Isn't that good?
So, I mean, let's go straight on to our two hypotheses. H0, the null hypothesis, is going to be, as I think we said when we started the last chapter, basically the status quo. Nothing has changed. So we will say that P is still 2/5, that the new drug is not any better. And I would, P equals 2/5, I ought to have said here for new drug. P equals 2/5 for new drug, i.e. the new drug is not any better than the old drug.
Would it not be P is less than or equal to 2/5?
Well, we just say no change, so no change at all. The H0 has always got an equals in it.
Okay.
H1 won't. H1 is that P is now greater than 2/5 for the new drug, i.e. the new drug is better. Than the old drug. So if we've changed our problem into that, what do we usually write down at this stage? Yeah, whether it's a one or a two-tailed test, and because that's a greater than sign in there, this then will be a one-tailed test. Just like last time, there are a couple of methods you can carry out these tests. We're going to do the easy one first. We'll just write down here again that we had the significance level of 5%. So that's just formulating our question, effectively. Now what we're going to do is to work out a way of coming to a conclusion. Are we going to accept or reject H0 or H1? So this is our method that we are going to use. We are going to find the probability of getting our observed result or better than that under the conditions of H0. And then if the so what we're saying there is going to find the probability that we actually would get 11 or better than 11 results if P really is 2/5, because that's what it states in H0. And then if that probability is less than our significance level, so if the probability of getting what we have seen is smaller than 5%, we're going to say, hang on, it's so unlikely to have happened, we don't believe it is 2/5 anymore. We will reject H0 and we will accept H1. So if our probability is small, we will reject H0 and therefore accept H1. However, if the probability is greater than or equal to our significance level, we will just accept H0, saying, well, there's quite a high chance that could have happened anyway under the old drug, so no evidence of any change. So that's the methodology we'll use, and at this point I'll just stop this video clip and I'll start another one.